Okay, well, the solution to the differential equation is almost trivial because you guys are experienced with that. So we can solve this equation, put the initial condition on it, and we get this. We can evaluate A and K if we know all the details of the circuit. And that's really quite easy. But let's understand what happens and why we have this decreasing exponential approach to some final voltage, okay? Or some final charge. Yeah. Okay, so what happens as soon as we close the switch? A little bit of charge is transferred, right? And we're pushing positive charge away from here and negative charge away from here, and the result is whatever your charge carrier, you end up with a little bit of positive charge in this plate and a little bit of negative charge in this plate, right? So a little bit, it looks like one word, a little bit of capacitor voltage does what? The capacitor voltage is opposing the voltage of the source, right? Okay? Now, let's think about what that means. Really, what you start with is initial field in the wire is due to the source voltage, right? Make sense? Right. Initial field in the wire just due to the source voltage. No charge has been transferred, but instantly charge begins, almost instantly. At the speed of light, the electric field gets distributed through the wire, or close to the speed of light, which is practically instant unless you have a really long wire. So you instantly then, or almost instantly, start getting a drift of charge, which creates some small positive charge here, negative charge here, right? And now you have the capacitor that has a voltage in this direction, source that has a voltage in this direction, the net electric field is going to be less than before. Okay? Resulting, my L and my U got smushed together because I didn't put the L in, resulting in less field in the wire. Okay? So, less rate of charge transfer. Okay? So less current, that's almost unreadable. Okay? And then I'm just going to put et cetera, dot, dot, dot. A little more charge is transferred, but not quite as much if you have the same time interval, right? And now you got more voltage here opposing this voltage, less current. Okay, and you think it back to the electric field, think about why that is, okay? I mean, if you're going from here to here, there's a loss of voltage between here and here due to the capacitor, but as soon as you cross this thing, there's a gain in voltage in that direction, right?
I gotta make up some shades.
So your net potential difference between here and here is going to be the sum of the potential difference across the capacitor and across the source. Okay? Okay, well, anyhow, that goes on.